that glass piece right here that wraps around as a window. And there might be a really simple way to model this in Revit using some of the standard tools, but I haven't found it yet. So if somebody does, feel free to chat with me later. But the method that I'm going to use is I'm going to model that in section using custom components. Okay, so to do that, the first thing we need to do is cut a section right through that window. So I'm going to go to my roof plan, and I already have a section, and it's not really super important to me. So I'm just going to move that down. If you don't have a section, then it's as simple as going your section tool right here, or you can go to View, Section, and I'm just going to draw that section right through that location. And I want to make sure that my view plane is extending far enough away that I can see a little bit of what's happening there. Okay? So given that section, I know that's where I'm going to do some of my drawing. Sections, section 1. Right? That way I can see really well where that window needs to lie. Okay, and the tricky thing about this, there is a tool, architecture, it's in here someplace, I think. There is might be under roof, actually. Roof. There's something in there for slope glazing. Okay, there is a tool for that. And so in theory, we could use that. But what I haven't been able to find is a method that lets us do the butt joint on the glass that turns that corner correctly, that the Horizon House has. Okay, so that's why custom component is probably the right way to go with something like this. Okay, so what I'm going to do is, starting from my three-dimensional axonometric view, I'm going to go Component, Model in Place, and I'm going to do a generic model. And by the way, you guys, I'm going to go fairly fast through this because I do want to get through the hidden line drawing creation in this course, okay? So this is kind of one of those things. I'm not trying to leave anybody behind, but if I've gone too fast, just come back to the recording later, okay? So generic model 1, I am going to set my reference plane by picking this inside edge. So I'm going to pick a plane, and I'm selecting the inside edge of that wall. Right? So it's right here. So from there, I'm going to go to my section 1 view, and I'm going to go create extrusion. And it's really wanting me to pick a plane again. That's kind of weird. Yeah, I'm going to do the exact same thing. I thought it would hold that plane for me, but it didn't, which is fine. It's okay, Revit. You can do that. So I did pick a plane, and again, I selected the inside edge of that wall, and I'm hoping that this is going to draw in the correct plane now. And the first step for me is to draw in my mullion for the glass. So I'm just going to trace that outside line, and I'm going to turn off thin lines, or turn on thin lines, actually, so I can see things a little bit better here. I know my mullion, my default mullion, well, I'm just going to guess here. Let's go 4 inches thick. So then I can use my offset, 0.4 for 4 inches. So I'm going to offset that mullion in 4 inches, down 4 inches, and then I need to connect this piece together. And if you'll notice, that mullion is thicker than the roof, and that's okay. We're not to the interior yet. So essentially what I've built is a mullion that does that. Okay, it's a sort of dogleg shaped mullion. And I know I want to give that a thickness. I'm extruding that toward me. So that extrusion is going to be, how thick are those mullions? 2.5 inches? Really should have looked at that before I started this. I think they're 2.5. It's like 2.5 by 5 maybe. So I'm going to do 2.5 inches, and that's going to be the depth toward me. Okay, so I'm going to go back to my 3D view before I accept that. I want to verify that I've drawn that on the correct plane. And then I'm going to green checky box that and make sure that it goes away from the wall and not into the wall. Cool? That 2.5, the inch symbol, I went to my axonometric view so I could see it a little bit easier, and then hit OK. So at this point, I'm kind of in pretty good shape. Really, it doesn't seem like it's almost done, but it's really almost done if you're thinking about this as a computer. Because the next thing I can do, I'm just going to go to an overhead view in my axonometric. I'm going to select that mullion, and I'm going to go copy. Now, as I copy that, that is going to want to stay attached to the reference plane. But I can turn off constrain. That means it's no longer attached to the reference plane. And I'm going to select inside edge to inside edge. And now I have 2 mullions. Cool. Next thing that I'm going to do, I need to make the top up here, bottom down here. Okay, so to do that, so like if I'm doing a custom window, I always start frame first. I like to work the frame in so that way I know exactly where the glass needs to land. Okay, so on this one, I'm going to continue to work sort of in that sectional view. So I think it's going to be a little bit easier. So I'm going to go back to my section 1 view. And I'm going to come to this location, create, extrusion, pick a plane. I'm going to pick the inside edge of that mullion. Okay, so I'm now modeling not on the wall anymore, but on the mullion. And I'm going to go the bottom part of the frame, so over 4 inches, up 2.5 inches. And I'm boxing that one off here. And then I'm going to go up to the top and do the exact same thing. I'm going to make a mullion that comes here to here, except that was a terrible last click. Okay, so I've got those 2 pieces created. One at the top, one at the bottom. And then the easiest way to do that extrusion is, again, to watch it in 3D. So I can see one at the bottom, one at the top, green checky box. And I'm going to use my grips right here to bring that right across until it snaps to the inside face of the other side. And that gives me those built for my mullions. Okay, so I know the glass is the last thing to do. I'm going to go back to my section one more time, and I'm going to go create, extrusion, pick a plane, pick the inside edge of that mullion again. And I know in this case, that glass is going to run almost all the way to the outside edge of that mullion. So I'm going to start by drawing the outside edge of my glass along the mullion, just like that. So again, I'm following that shape, and then I'm going to use my offset tool. I'm going to bring it in 1/4 inch. That was 2 1/4 inch, 0.25 inches. There we go. So I'm going to offset it 1/4 inch in, like that and that. And then glass is typically right around 1/4 inch as well. So I'm offsetting again 1/4 inch. So you should have 3 lines. The outside edge, the outside of the glass, the inside of the glass. Okay, I'm going to go ahead and delete my 2 outside edges. And then I need to finish off the glass because, again, extrusions have to be closed loops. So I'm closing off the bottom of the glass, and then I'm going to close off the top of the glass, and then I'm going to trim the lines at the top of the glass. So you can see that is where the glass is connecting to the mullion. Not particularly accurate, in terms of what really happens, because the glass actually goes into the mullions, it has stops, all that stuff. But a very good and reasonable, quick version of a model. Okay, so I'm going to zoom out. Again, I'm going to finish my extrusion in 3D by taking that grip and sliding it over so it snaps to the inside edge of my mullion. And that is a very, very fast way to model a custom window. And again, yeah, it took 10 minutes or whatever to do it this time. But in the future, when you're working on something like that, I mean, that is about a 2-minute process to build that window once you've done it a handful of times. Easy peasy. Not as fast as putting in a curtain wall for sure, but when you have sort of a custom situation, it's a really, really fast way to do it. Is just model it in section. Sides, top, bottom, glass. Okay? So the one other thing that I might do really quickly, because this is going to become very relevant very soon, is switching this to actual glass. Okay? So to do that, and we're going to get much further into these techniques on Wednesday, but we need to change some materials. So I'm going to select that center piece. And notice I am still in the family. Okay, so to clarify that, if I click Finish Model, I'm now in the Revit object, right? I'm no longer editing my generic component or my generic model, my family. I'm editing everything. To change materials on this object, I need to be editing that object, right? So I'm going to select it, edit in place. Now I can select the glass. And you'll see right here, if I scroll down, I have material, and it will say by category. That basically is going to tell me, right now it's set to the default material, which is like vanilla gray. So I'm going to click once on by category. I've changed that a little bit. There it goes. You'll see, you have to activate it, and you will see these 3 little dots, the ellipses. It's a very standard thing in software to say there are more options available, right? So I'm going to select the 3 little dots, and that's going to pull up my menu for materials, and I'm just going to switch this to the default Revit glass, which is called glass, and say okay. And now you can see it's applied that as a translucent material, the same as my storefronts. And now I can say Finish Model. Cool? Yeah. I don't know. No idea. Select that. Edit type. Aluminum. Yeah, so if you wanted to do that, you can do that as well, for sure. I'm kind of saving that a little bit for later, for Wednesday, which is totally fine also. Okay, so hidden line drawings, right? So part of the assignment, again, is 2 perspective hidden line drawings. Revit really does excel at line drawings, okay? It is not particularly adept anymore at doing renderings. That's why we're using Twinmotion. It's also not very good at getting us immersed into a form. That's also why we're using Twinmotion, okay? But it does do an excellent job of hidden line drawings, plans, sections, elevations, and perspectives. So use it at what it's really, really good for, okay? So to do a really good and interesting perspective, and let's just look at where I'm at right now in this. So I'm a little bit further behind than you guys, and also I've really messed up this bridge thing because that should come all the way over to here, I believe, but that's okay. I'm just going to work with what I've got, all right? So I know for me, the first image that I'd like to build is something at the bridge looking across to the house. Okay, so I'm going to go to my plan view, my level 1 plan view, And I'm going to zoom out. And I'm going to go to, I've got two options to get there. I've got view, and right here next to the default 3D view. So again, the default 3D view, you guys, it's an axonometric drawing. It has a scale to it. And every year, I say this, every year, several of you mess this up. I'm looking for perspectives. Perspectives are immersive, axonometrics are volumetric. Not looking for volume. I'm looking for immersion on this. What's it going to be like standing in this location? That's what we want to convey. Axonometrics have their place. They're about volume, sometimes material, sometimes constructability, right? We want to get into this idea of displaying a project in its immersive qualities. So I'm selecting camera. I can also go up here, select the little bitty arrow, and go camera. Your first left click is where the camera is located. So I'm going to go someplace close to the edge of the bridge. Your second left click is your point, what's it called? Your target. I'll just call it a target. And it's important to note, I need to move that target all the way past the edge of what I want to see. If I select right here, your view literally stops where that target stops. Okay, and it exists that way for a reason. If I have a whole city, so maybe I only want to show a portion. So I'm going to move that past the edge of my building, and that will open up that view. Now, first thing, the view that it creates, it's going to position the camera 5 feet 4 inches, or sort of a default eye height, above the floor plan that you're viewing from. It's also going to create a sort of 4:3 aspect ratio image, which kind of stinks. We have a tendency to see the world much wider than we do high. That's sort of a natural selection thing, maybe. I don't know. We could debate it. But we do. I mean, there's a reason, like, I was talking about this in section 1. The Oscars last night. That was exciting, y'all. Yeah. Most films are shot 16:9 as an aspect ratio, right? So 16 wide by 9 high. Because it's closer, it feels more like we're part of the story, part of the action. 4:3 is like really old, what I used to watch growing up, TV. So I have no idea why that's the default, but that's the default. But what I would tell you is that's typically not what we want to work with. So first thing I'm going to do is stretch that out and get it a little closer to a 16:9. I'm also like things like rules of thirds. So I don't have a lot of time to discuss cinematography and cameras, photography in this class, but I'll be throwing out some terms like rules of thirds, things like that as we're working through it, things that you want to pay attention to. Okay, so that's a decent default setup, but I really don't like it. The reason why I really don't like that as an image is it's really flat because I only have one side of the building. So even though I really want to be on the bridge, I'm actually going to shift my camera off to the left of the bridge because that's a terrible image. Okay, it just doesn't have any depth at all. Once you get past the bridge, zero depth. So I'm going to go to my plan view again. Level 1 plan view. And I need to see that camera. So there are two ways to do that. The first one that I have is I can come right down to here. I've got 3D view 1 and 3D view 2. 3D view 2 is the one that I just created. 3D view 1 is a view more like what I want to have. Okay, so I actually need to delete this one. I made that one earlier. Okay, I'm going to rename this one first. Right click, rename bridge view 1. Please name your views. For the love of all things nice, please name your views. It'll make your life so much easier. When you're like third year, y'all, if you're working in Revit, you're going to have like 40 views. Most of you, it'll be 3D view 1 through 3D view 40. And you will spend 45 minutes trying to look for the right view rather than just taking the 1 second to name it. So as you make them, name them. Okay? Good habits. Okay, so I'm going to go to my level 1 plan view. I can right click bridge view 1 and say show camera, and the camera pops up. And I can then just left click and drag that to a slightly better location, because it just looks so much nicer when I can see the side of the building, for sure. And I'm going to sort of squish that view over a little bit, again, kind of lining up a third and a third, right, to kind of create that as something that's kind of working well for me. I'm going to pull that bottom view down just a little bit too. Okay, so the things that I need to do with this now, if this is the image that I'm working with. All right, that's odd. I'm not sure I'm not getting that back edge line, but we'll see if it shows up here in just a second. This is your default line weights, and it's no good. I see this as the quality of line drawing all the time in architecture school, and it makes me crazy. Because fixing this, making this look a lot nicer is just super easy, you guys. And what I'm going to show you is very formulaic, but it works very well. So right down here at my graphic display options, I want everybody to activate graphic display options. And let's go through this list. First, I'm going to keep my style set to hidden line. Right? You can go shaded and consistent colors, but Revit doesn't excel at those nearly as well as it does with your hidden line work. Okay, next, I'm going to activate smooth lines with anti-aliasing. So it's a little bit tricky to see on the bridge. It's much more obvious here. The lines look staggered. They look like they're stepped. That is called aliasing. So what we want is anti-aliasing. You can think of it as like when a weather reporter, it's not as bad now as it used to be. Like if you can think back to your childhood, the days before HD TV, when the weather reporter would wear a bad tie on TV and the whole thing looks like it's crawling around in his gut, right? That is aliasing. And what we want to do is turn it off or turn anti-aliasing on. It adds more color along the line, sharpens everything up. So I'm just going to do that and hit apply, and you'll see the result is really instant. Really, really instant. Make sure that that's turned on. I see drawings with that turned off all the time. Makes me crazy. Okay, it just really changes the way it looks. Next, silhouettes. I'm always changing my silhouettes to wide. So this, what essentially is going to happen with that is Revit is going to look for edges, and it's going to make edges wider. And that is going to give us the hint of an indication of line weight. And it's going to create a drastic improvement. Next, shadows. I'm going to start just by turning on cast shadows first. And actually, this helps quite a bit. But I'm not going to use it in this particular case because I don't want to go over today how to reorient the sun. But typically, if I have shadows on, I want shadows going away from the camera. Okay? And what I mean by that, this shadow right here is coming towards the camera, which is why this edge is in shadow. Once I put an edge in shadow, it loses its depth. I can't see the ins and outs, right? So I typically, 9 times out of 10, want shadows going away from the camera. So I'm actually going to turn that off and turn on ambient shadows. Ambient shadows create a good sense of gradient across a surface. So you can see like this corner here is lighter than this surface here. So it's calculating the sun is in sort of this location. It's going to start giving you gradients across surfaces. Just kind of makes things pop as a hidden line goes. Okay? And I don't necessarily need them, right? But it gives a little sense of grayscale. It's kind of nice. Looks like you've taken a pencil and kind of shaded things in a bit. Next, sketchy lines. Sketchy lines are sometimes yes, sometimes no. For this particular thing, I'm definitely going to turn sketchy lines on with 2 as a jitter, 4 as an extension. And so sketchy lines simply make things look a little bit looser, a little bit more hand-drawn. When you are working with clients, really an important setting. If I am early on in the process, and so you'll see this in Community Studio. If I'm early on in the process, I really don't want to show hardline rigid drawings because the feedback that I'm going to get from clients is much more directed towards, well, you're done, so I'm not going to say anything. So when you're trying to work with the client to get valuable qualitative information, you really want to show them looser, more organic looking things. They feel better about critiquing your work, which is exactly what you want. If you're going to do good work with the client, you need good feedback. Okay, you will see that play out in Community Studio. I guarantee you. And that's also like early meetings with the client in Community Studio. I would not show them renderings coming out of Twinmotion at all. It would be all of this kind of work so that they feel as though everything's still on the table, everything is open for discussion. Next, depth queuing. If somebody can get depth queuing to work, that would be awesome. I can never get it to do anything for me at all, so we're going to ignore it. Lighting. This is where we can tweak the sun and say, no, we want shadows casting away. So we're going to ignore that from now as well. Realistic, this is off right now because we're in a hidden line style. We're not actually doing a rendering. Background can be useful, but I think for this assignment, you're probably best leaving it off. I can set it to sky, and it just, yeah, no. Gradient works depending on the site, and also I can really quickly modify or tweak these colors to make it even sort of less aggressive. But for this assignment, typically I'm going to say leave it off. Also, you notice if I need to incorporate it into a photograph, I've got image, so I can do that as well. But they really didn't give us any tools other than putting an image in the background to actually do a photo match. So that's a really good default set of settings, okay? I should always see, like on your boards, line weights, those kind of things, because this same technique works great for elevations. Okay, so I should always be able to see line weights, things like that. So I'm going to hit apply and OK. And I have this almost ready to export. The key thing with this, though, is as an image, I don't know the resolution of this. Okay, so to understand the resolution of this image, I need to select my border. Okay, from the border, I'll have this little button right here that says size crop. When you activate size crop, I get my width, my height, and these two radio buttons, field of view and scale. For a typical hidden line drawing, you want to be either letter size or legal size. So I'm going to show you guys how to set this up as an 11 by 17. And so I want to show you what not to do first and then what to do second. So I'm going to set my width to 17 inches. Now, if I have the radio button here selected, field of view, all that's going to modify is my field of view. So it's going to go from what it was, 11 something, to 17 inches. So if I hit apply, it does that. It stretches out my field of view. It doesn't change my resolution. Okay? So I'm going to set that back to 11 inches. With that selected, if I go size crop and select the scale or lock proportions, now when I change this to 17 inches, once I click in the height field, you're going to see it stretches both. Right? So it doesn't look like it's done anything, but what it has actually done is given me more data. It's given me a higher resolution, a larger image to work with, which is what we want. Right? The default size is, again, like 4 by 5, something like that, which is postcard size. And usually when these are headed to our boards, you at least want to start with something larger. I can always shrink it down, but you really can't go into your image editing software and blow something up. It's going to lose its resolution. So starting with about 11 by 17 works really well. So let's hit apply and OK. To export this, I'm going to go File, Export, images and animations, and image. Your default is usually fit to, which is ridiculous. Don't use it. We're architects. We want zoom to 100. I meant 11 by 17-ish when I typed in 11 by 17-ish in my field of view, or in my watch proportions box. Okay? JPEGs are super easy to work with, so I'm going to stick with that, except I want to make sure that JPEGs are set to lossless. Again, we're treating this as if it is headed to print, even though we're headed to web. If I knew that this was only an on-screen internet presentation, 72 DPI would be just fine. That's how many dots per inch I'm creating. But because I want you thinking more about print, you need to be 150 or 300. And so for this, I'm going to select 150 dots per inch. So we're somewhere in the range of 17 inches wide, 11 inches tall, 150 DPI. We are printing out the current window, and I need to change. This is saving right here to users dbeach01 desktop Horizon House. And actually, I'm totally fine with that as a name. Let me put after that actually bridge view. And then I'm going to say OK. And this is pretty close to instantaneous. By the time I minimize all my windows, I should have Horizon House bridge view outside of Revit. That gives me just enough time to do Q&A. So do some question and answers, and we'll start on Wednesday. We'll start with a different view looking up at Horizon House from the slope, and then we'll drop that into Twin Motion.